Welcome to today's Explainer. We are jumping right into a truly groundbreaking 2026 study published in the Proceedings of the National Academy of Sciences. Brought to us by researchers over at Keio University and the Japan Science and Technology Agency, this research is outlining a fundamental paradigm shift in how we understand human physical capability, and it's all driven by some incredibly cutting-edge neuroscience.
So, I want to start by posing a question. It kind of challenges a core assumption we all hold about physical improvement. Can you get physically faster? Like, can you actually improve your muscle reaction time without moving a single muscle? Instinctively, we'd say no way, right? Physical training requires physical movement. Well, as you'll see from the data we're about to review, the answer is a definitive yes.
To understand how this is even possible, we have to look at what we currently call imaginative training, or motor imagery. You know, athletes, musicians, performers, they use mental imagery all the time. They picture that perfect golf swing or the exact finger movements on a piano. But historically, there's been this massive limitation. It's a complete black box. When an athlete imagines a movement, neither they nor their coach can actually see if the brain is firing optimally. You're basically just crossing your fingers and hoping that mental effort is doing something useful.
Well, that black box is exactly what brain-computer interface, or BCI technology, absolutely shatters. According to the research team, BCI takes your unconscious invisible brain states, visualizes them, and feeds them back to you in real time. By doing this, it enables self-regulation. Basically, it's like a mirror for your mind. For the very first time, you can look at a monitor and see exactly what your motor cortex is up to while you were just sitting there thinking.
Okay, let's dive into this. The researchers built this mind mirror using a high-density, completely non-invasive EEG cap. We're talking no implants, no surgeries. The cap just reads scalp electroencephalogram signals, specifically targeting the motor cortex. Then, an AI translates those highly complex brainwaves into a super simple visual on a monitor, just a red bar. The height of that bar changes in real time based on the spectral power of the user's sensory motor rhythm. And the user's only job? Simply control the height of that bar using nothing but their thoughts.
Now, the press release from Keio University and JST highlights three distinct breakthroughs here. First, as we just talked about, it visualizes these brain states using only AI and wearable sensors, so it's highly accessible. Second, it proves you can improve physical ability via mental imagery without needing a gym, a track, or any physical space at all. Time and location literally no longer restrict your training. And third, maybe the biggest game changer, it shifts the focus from training the muscles to directly training the brain itself. Let's look at how this builds an entirely new framework for sports science and physical therapy. The researchers put it perfectly. Training the brain, the master controller that sends commands to the muscles, improves actual physical performance. In older tech-assisted training, we were always measuring the hardware, right? Heart rate monitors, EMG sensors on muscles. But this BCI approach goes straight to the source. Instead of upgrading the hardware, this technology provides a direct software upgrade to the body's master controller. Section 1. The BCI experiment, proving the paradigm shift. Let's look at how they rigorously tested this.
To make sure their results were absolutely ironclad, they ran a double-blind, randomized control trial. They split participants into two groups. The real feedback group got that visual red bar perfectly tracking their own real-time alpha band brain activity. The sham or yoked group, they went through the exact same motions, but the red bar they were watching was completely fake. It was just a playback of someone else's brainwaves. The absolutely crucial variable here is that both groups practiced mental imagery, but only one group had an accurate mirror reflecting their own actual mind. The mental task they did was incredibly simple. The protocol asked participants to alternate between two basic states. First, motor imagery. They mentally imagined opening their right hand. Then, relaxation. They just mentally relaxed the muscles of their right fingers. By doing this back and forth, they were intentionally trying to modulate their individual alpha frequency in the sensory motor cortex. Now, what's really interesting about this slide is what happens afterward. The researchers wanted to know, does this training actually stick? Can participants still control their brain states when the BCI screen is turned off? The data emphatically says yes. The real group, the ones with the accurate feedback, successfully reorganized their sensory motor neural dynamics. They actually rewired their brain's ability to control these states on demand, even when the visual bar was taken away. To make sense of these complex neural dynamics, the team used a data-driven approach called a hidden Markov model,
But hey, we don't need to get bogged down in the advanced math here. What you need to know is that the BCI training improved what's called cortical state switching. It's exactly like shifting a car into the right gear. The real group learned how to rapidly shift their brain's gears from a resting state right into an active motor state, which massively enhanced their mental and behavioral flexibility. And this brilliantly illustrates the ultimate payoff of the entire study. After just 2 days of mental training with BCI, they tested the participants' actual physical reaction times. If you look at the real group compared to the sham group, the participants who accurately trained their master controller significantly shortened their physical reaction times. That's for both muscle onset, actually contracting the muscle, and muscle offset, relaxing it. They got physically faster without ever moving a single muscle during the BCI training. It's incredible.
Section 2. The future of human augmentation.
So what does this all mean for us outside the lab? The researchers point to 3 massive real-world applications. First, in medical and healthcare. Actually, a university startup named Lifescapes has already turned this BCI tech into a medical device. They're rolling it out to 60 medical institutions in Japan right now to help restore motor function for patients with severe stroke paralysis. Second is human augmentation, literally giving healthy people the ability to push beyond their physical limits by optimizing their brain's control signals. And third, sports. Imagine an athlete perfecting their physical performance from a hotel room or while recovering from a broken leg, completely independent of time and location.
This 2026 study definitively proves that the mind isn't just along for the ride. It is a highly tunable control system, which leaves us with a totally fascinating thought to consider as we wrap up this explainer. If your mind had a user interface, if you could literally sit in front of a screen and directly train your brain's software, what physical skill would you choose to mentally train? The era of upgrading the master controller is officially here. Thanks for joining me today.